Welcome to graphing square roots. You probably have not graphed these before unless you've tried it on your calculator. We're going to start with the base, or what we call the parent function, and make a table and graph it so we can see what it looks like. Now, remember, if you're taking the square root of something, you cannot take the square root of a negative number and get a real number to plot on our coordinate plane here. So, if you're going to make a table, we should put values in for x that we know the square root. For example, I would start with 0. Square root of 0 is 0. Next, I'd go to 1, because I know the square root of 1 is 1. Next, I would go to 4, because I know the square root of 4 is 2. Next, I would go to 9, because I know the square root of 9 is 3. And then the next one would be 16, but I think I'm getting too big to plot it. One thing that I find interesting is if you have the perfect squares here, they always go up by the odd numbers. So from 0 to 1 is an increase of 1. Then it's an increase of 3. Then it's an increase of 5. Then it would be an increase of 7. Just something interesting about your perfect squares is that the difference is odd numbers. If I plot these points, 0, 0, that's where it starts, and then 1, 1, and then 4, 2, and then 9, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9, 3, and I could keep going, but it starts at 0, 0, and it goes forever. I call it like the arm function. It kind of just looks like an arm hanging out over there. So that is what a basic square root function looks like. Now, let's try another one. And when I try another one, I'm going to do this one in a different color on the same grid. I'm going to slide down here so we can see it. I'm going to try this crazy one right here. Now, what I advise is, again, you pick x values that will work out nice for you. For example, I usually say if there's stuff underneath the square root, start with an x value that will make the radicand equal to 0. Why? Because I know the square root is 0. So the first x value I'm going to put in is negative 4. Why? Because negative 4 plus 4 is 0. Square root of 0 I know is 0. 0 plus 2 is 2. That means the arm will start at that point, because that is the first spot where we'd be taking the square root of 0. Anything smaller than that will cause a negative number to be taking the square root of a negative number. We can't have that. So always start with that. And just like with the other ones, the next one I would pick is always one bigger. So I would go to negative 3. Why would I go to negative 3? Because negative 3 plus 4 is 1. Square root of 1 I know is 1. 1 plus 2 is 3. So I went up by 1. Now I'm going to go up by 3. Why am I going up by 3? Because if I plug in a 0, 0 plus 4 is 4. Square root of 4 I know it's 2. 2 plus 2 is 4. So I went up by 1. Then I went up by 3. Now I'm going to go up by 5. Why? Because if I plug in a 5, 5 plus 4 is 9. Square root of 9 is 3. 3 plus 2 is 5. So I went up by 1. Then I went up by 3. Then I went up by 5. Then I could go up by 7, but then 5 plus 7 is 12. I would be off my grid. Okay? Now, I'll be honest with you. Nobody told me this when I was in school. I just started putting in any x values I'd want. I'm sure I started with negative 4, but I would plug in maybe a negative 2, a negative 1, and I'd get some gross decimals. This is a nice way to make a table and get just nice whole numbers to be able to plot. So let's plot these. We have negative 4, 2, 1, 2, 3, 4, and 2 up. Negative 3, 3, 0, 4, 5, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. Again, it must start at that one. And now my arm has moved. If I look at it compared to the parent function, so this was my equation, it actually moved left 4 and up 2. We've actually seen this with parabolas. It's the opposite of that in your brain, at least I like to think of it, because it's left of that, so it's at -4, and keep this one the same. So -4, 2 is where it starts at. My A value is a 1 here. We don't see that. That just means it's opening just like the regular arm. It is not being flipped over. So you'd switch this and keep that, just as a little help on how that would be transformed. Okay, let's try another one. And again, let's decide what x values to plug in. I'm going to plug in a 1 to start, because that's what would make the radicand here 0. 1 minus 1 is 0. Square root of 0 is 0. 0 times -1 is 0. 0 minus 3, -3. So I know this graph is going to start at 1, -3. And you also can see that here. Flip it, keep it, like right here. 1, -3 is where it's going to start. Then I'm going to make the number go up by 1 to start, because if I plug in a 2, 2 minus 1 is 1. Square root of 1 is 1. 1 times -1 is -1. Minus 3 is -4. So now it is 2, -4. So it went up by 1. So now I'm going to go up by 3, because the next odd number after 1 is 3. So 2 plus 3 is 5. 5 minus 1 is 4. Square root of 4 is 2. 2 times -1 is -2. Minus 3 is -5. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 5, -5 is here. So again, I'm starting to see my graph. I went up by 1. I went up by 3. Now I'm going to go up by 5. So now I'll be at 10. 10 minus 1 is 9. Square root of 9 is 3. 3 times -1 is -3. -3 minus 3 more is -6. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6. So here is my arm. And if you remember, this was the formula that I said can help you a little bit. Doesn't mean you have to memorize it or anything. It starts at opposite 1. Keep this -3, so it starts at 1, -3. My A value is negative, so instead of my arm opening up, this one is actually opening down. Let's try another one. So we have this guy right here. Again, I'm going to start with what value of x will make my radicand 0, because I know the square root of 0. I'm going to choose -3. -3 plus 3 is 0. Square root of 0 is 0. 0 times 3 is 0. 0 minus 1 is -1. I'm sure it is no surprise that this graph is starting at -3, -1. Flip it, keep it. And then I'm going to make my numbers go up 1. So I look at my x value, which was -3. Now I'm going to make it -2. -2 plus 3 is 1. Square root of 1 is 1. 1 times 3 is 3. 3 minus 1 is 2. So now I have the point -2, 2. I went up by 1, so now I'm going to go up by 3. -2 plus 3 is +1. 1 plus 3 is 4. Square root of 4 is 2. 2 times 3 is 6. 6 minus 1 is 5. Next point is 1, 5. 1, 2, 3, 4, 5. All right, so I went up by 1. Then I went up by 3. Now I'm going to go up by 5. So 1 plus 5 is 6. And you'll see why. 6 plus 3 is 9. Square root of 9 is 3. 3 times 3 is 9. 9 minus 1 is 8. So I'm going to plot the point 6, 8. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8. And I could do more. I added 5. I'd have to add 7. Then I'd be off. So I just want you to look at this. Here was my regular parent function. The regular square root x is like this. So now I made a lot of adjustments right here. I shifted it 3 to the left and 1 down, and then my A value was a 3. And what that does, when there is a positive number here larger than 1, it stretches it. It makes the arm shoot up a little bit higher. If that would have been negative, it would have been just as open, but it would have been opening on the bottom side. If that number would have been less than 1, it would have just not been opening or quite as high. Just some things to think about. It's always a good idea to have an idea of what a graph may look like before you make your table or put it in your calculator. So I hope that helps you to be able to graph square roots without a calculator, and I should say more importantly, understand why your calculator is giving you that shape. Thank you.